Hello, welcome everyone. Myself Basras Patil, and today we're going to see what are the open systems and the closed systems, or else isolated systems. There are total three types of these systems: open, closed, and isolated system. So, why we have to consider these systems? Because entire universe itself is one of this system, or else if you are having a refrigeration in your home, or else AC engine, wherever the thermodynamic process takes place. That where the process where it taking place, it is called as a thermodynamic system. So first of all, we need to understand that one, thermodynamic system. Okay, so uh, thermodynamic system itself is having some boundary, and inside the boundary there is a thermodynamic process. So then only we can call it as a thermodynamic system. So here, whatever the examples are, can you see on the screen? Here there is a thermal power plant. Then here there is a heat exchanger is there, refrigerator is there. Okay, then here there is a AC unit in the IC engine. So AC unit is used in the home. So the different products are utilized in the home and industries as well as vehicles. So in these systems, there is a certain amount of heat exchange. There is exchange of heat. So already I have told about the heat means what? It is the energy. So we measure the heat in terms of the joule. Okay. So that heat, whatever it is exchanged, or else it is processed, or it is given out, or else it is taken inside. So wherever this process is taking place, or else heat is stored, there will be a thermodynamic process. Then that thermodynamic process, wherever it occurs, this that is called as a system. So thermodynamic system is nothing but it is having the boundary, and outside the boundary, uh, there will be it is called as a surrounding. So this everything, if I consider this thermal power plant, so whatever the outside this thermal power plant is there, we can call it as a surrounding. And inside this one, there will be a thermodynamic process. So this is thermodynamic system, we can call it this one. Okay, thermodynamic system we can call. Now inside this fridge you can see refrigerator. So whatever the cold is maintained, that it is maintained due to the thermodynamic process. So that process is called as thermodynamic process, and this entire system is called as a thermodynamic system. So let us see what are the definitions of these open system, closed system, and isolated system. So total, as I told, there are three different systems. It is open system, closed system, and thermodynamic system is a specific quantity of a matter or a region. It is a specific region, matter or a region in the space chosen. Okay, based on the interaction of the mass, energy, and the surrounding systems are classified into three types. So systems are classified into three types. That is closed system, open system, and isolated system. I told. So in the closed system, the always the energy transfer is there uh, across the boundary is it is a boundary but does not allow the matter transfer. Okay, in the closed system there will be a energy transfer. Only energy transfer can takes place. So here it allows the energy transfer only. Do not allow does not allows the mass transfer. So if I take refrigerator, here the example they have given pressure cooker. Okay, and then s- sealed can of a soda at a room temperature, car engine cylinder, and the gas in the piston cylinder arrangement. So these are the uh, closed system. We can call them as a closed system. These are the closed system. Why we can call this as a closed system? Because in the pressure cooker, when we add some rice for cooking, so energy will be only transferred. Whatever the heat it is there, it will be taken in, and the energy will be transferred. No uh, mass, whatever it is there, it will be not transferred. Or else similarly, in the you can say in the refrigerator also, whatever the energy is there, it can be transferred, but the mass, actually the substance, whatever it is there, it cannot be transferred. So that's why mass will be remains constant, and heat and work can cross the boundary. Means if you specify certain space, out of that space it will not going to travel. And also called as this process is called as a controlled mass system, because the mass is not changing, mass is remaining constant. So that is called as a closed system. Then comes the open system. In the open system, if I taken a system, so mass as well as energy, both will travel out of the system, or else they may come into the system, or else go out of the system. Mass enters and mass leaves of the system. Heat and work transfer may occur. Also called as a controlled volume system. It is because whatever the mass it is going out and mass it is coming out in, we can control that one. So for some examples are uh, kitchen faucet with the water flow, air compressor is taking and expelling the air, a radiator, whatever that is there, it is used in the engines and all, radiator for cooling the water or else cooling the fluid. Then steam turbine, boilers are the examples of the open system. So in here also we can consider IC engine also, because in the engine, the air and the fuel will go inside the engine, and after combustion, there will be a burnt fuel, that is there smoke, we can call it as smoke. It is coming out of the engine through the your silencer. So there is also a mass and energy flow, so we can call it that as a open system also. So next one is the isolated system. In the isolated system, neither mass or nor energy, both are not traveling. Example, we can, there is no perfect isolated system. Entire universe we can call as isolated system, but there is no such a specific example we can call it as a perfect isolated system, because in this system neither heat nor work uh, nor mass it is transferring it, whatever it is there inside the system, it will remain same. Then only call it as isolated. But some examples we can consider with the assumptions we can make. Thermos bottle, insulated ice, then sealed insulated laboratory container we can call. If I take a thermos, when I keep a cup of tea or else hot water uh, inside this bottle, so it remains hot, but it will be remaining for certain period. Then after it gets cooled, because there is no perfect isolated system. But as we are assuming that it remains hot only, because neither the liquid whatever it is there inside the thermos it is going out, or else the new liquid it cannot be added. So whatever the liquid is there, it will be remain same, and the hotness whatever it is there, it will remain the same, that is temperature will remain the same. Then only we can call it as a isolated system. So these are the three different types of this system. So if we compare, in the open system, mass transfers, yes. Closed system, mass doesn't transfer. Isolated system also, mass doesn't transfer. Heat transfer, yes, yes, no. Then work transfers, yes, yes, no. So some examples they have given here again. So let us see here some examples you can understand clearly. Okay, same I have explained here. You have to see this. We will see this some examples. Okay, specifically. Okay, power plant. If I consider the power plant, uh, the boundary is drawn around where it is drawn around the boiler, turbine, condenser, pump. So these are into the systems only. Outside these systems, whatever it is there, it is called as surrounding. So um, this is a open type of a system. Thermal power plant is a open type of a system. Why? Because steam and water continuously will flow out of the system, as well as energy transfer also takes place. Okay, that's why we call it as an open system. Then refrigerator in the home, whatever it is there, boundaries drawn around the compressor, condenser, wall, evaporator. So this is the open system, because refrigerant continuously circuit through this system and the energy transfer occurs. Okay, energy transfer occurs here. Then AC unit, this is also open system, because here also the refrigerant flows through the system and heat is absorbed and rejected. Heat is nothing but form of a energy that is uh, absorbed and it is left out. So that's why you can call it as an open system, because in the open system energy will flow out of the system inside, mass remains same. So internal combustion, this is a we are calling it as a closed system, because no mass enters or leaves during the compression, but work and heat transfer may occur. So here they have considered in different way, but we can call this as an open system as well as a closed system. During the combustion only it is considered as a closed system, because during combustion there will be no exchange of the mass. That time it remains closed, but after that it is a open system only. Okay, during the intake and exhaust stroke, it is open system. As I told you, during the intake and exhaust of the fuel, it will be open system, because during intake, fuel and air mixture will be coming inside the system. Then it is the open system. But during combustion, it is a closed system, and after that, when combustion completes, the whatever the gases are there, they have to leave the cylinder. Then that's why we can call it as a open system. So here you can see the example perfectly. Here the mass is flowing in and out. Okay, mass. Then it is open, because mass and energy both are coming in and out. Here also mass and energy both are uh, coming and going out. Here also mass. So this entire system we can call it as an open system. But the process what it is happening in this circuit is called as a closed system. It is closed. Here also, so this portion is we can call it as a close. And in the IC engine, so this is the open system, because here gases will come in and flow. But during this compression process, it is a closed system. Here specifically, when we are during the operation only we can consider. But rather than that, you are not considering. But we can call this one a refrigerator as a closed system, because uh, only the same liquid will be circulating inside the system. No external mass, whatever it is there, it is not coming inside the system. In this circuit, in the circuit, we can say. So this is the open system. So this is open. Fridge you can consider as open, but the process what it is happening here, this is closed, because mass, whatever it is there, the liquid, refrigerant liquid, it will be circulating inside the this circuit only. No other refrigerant liquid is added. Same liquid remains there. Then okay, this is about the open system, closed system, and isolated system. In the next video, we're going to see the thermodynamic processes and some problems over that.